This is kind of the video lab manual, and thank you all for your contributions. Those of you that I asked, some of the senior students I've asked for slides, and thank you very much for those. So these slides will be available on the group drive and also the video for not just students who are already here, but also prospective students. So it's my hope that this kind of serves as a kind of our public exposure efforts as well. So group meetings are like this one, are weekly all year, and the schedule is sent by me before the start of each quarter. Individual meetings are every 4 weeks, and these are for all postdocs, PhD, and MS students, and all undergrads who are leading their own projects. So these are kind of individual project meetings. You can think of it that way. Subgroup meetings are every 4 weeks, and we have 4 different subgroups, and there's a lot of overlap now. So energy includes conjugated polymers, solar cells of all types. Synthesis includes organic chemistry. That's kind of what we mean by that. Sensors, nanoislands, instrumented robotics, and haptics. And haptics has a lot of crosstalk between the synthesis and sensors part as well, and also potentially in the conjugated polymer part of the energy subgroup. So each person, each grad student and postdoc is a core member of one subgroup, but then I've assigned kind of ex officio members to other groups. An ex officio member of a committee is somebody who's granted membership on that committee by virtue of being on another committee. So it's a way of increasing the entropic meeting death of the universe. But I really think it's useful to have certain people who have expertise across these, or who just want to learn what's going on in another area. So the core members have to present a couple of slides as to what they've been up to. That's usually worked up data, photographs of stuff, things that you want to share with the rest of the group. But ex officio members and people who just want to come to listen and discuss don't have to present anything. All right, this is no particular order, so we're gonna change gears a bit here. So time to graduation. So the rule of thumb is 1 original first author paper per year for 5 years or equivalent level of productivity. Finishing in less than 5 years is possible. 3 awesome papers are enough, as long as that is enough to get the position you want after graduation. Usually for a postdoc at a top 5 school, you're going to need more first author papers than that. For better or worse, it's just the way to stand above the crowd. And the second part, and no PI will ever really say this, but there's a lot of pressure on us on the PhD defense date, and I've been a member of failing committees before, and it is the most, not PhD defense. I've been on failing qualifying committees, so like Senate exams before. It's probably the worst feeling ever for every single person in the room. Obviously the student by far, but it's really a situation that weighs on us a lot. I would never allow any of us to get into that position, but it kind of is a thing where these are the defenses, and the exams are sometimes the only time when we have the opportunity to share our research with our colleagues. And our spokesperson is the student, and as long as I think the kind of under the table criterion for the PhD defense is a certain number of publications, being in a position to get the job you want after graduation, and impressing at the defense is an important rule of thumb. The job of a graduate student is to graduate. everybody's situation is different. So everybody's situation in the group is different. Every situation in other groups is different. So what you want to have is the PhD dissertation that really that you're really proud of, that represents the dossier that you want to put in front of a hiring committee and be assured that you have as good a shot or better than anyone else applying for that position, whether it's in industrial R&D, postdoc, faculty position, government, anything. Okay, travel policy. Conferences are really important for learning the context of your research. If it's just us talking to us all the time, then we don't really know where our work fits in with what everybody else is doing. So there are ways to learn about the context of what you're doing in other ways other than just going to MRS and ACS conferences. So go to as many networking events as possible. The reason that we go to these things is because we don't know what we don't know. So there could always be somebody there who knows how to solve your technical problem, has a job that you might want to apply for, or that you have a friend that might apply for. And usually these events, we kind of see them in our, at least for me, my social anxiety kind of takes over and like, no, I'd rather just not go. But almost always, I'm glad that I went. It's pretty rarely a waste of time, especially because my minimum delta G is just to like scroll through Twitter on my phone. So I'm gonna waste that hour anyway. I might as well like have 90% chance of not wasting it. I'm productive sometimes. All right, the meat of the travel policy. One paid conference per first author paper domestic, or half of the costs of an international conference. More than one per year is possible, subject to appropriateness of the, sometimes there's a conference that would just really, really benefit a particular person's research and the availability of funding. If you don't see one advertised, or if you see one advertised that you want to go to, you can propose it to me. In general, this one per year, or one per first author paper, the median has probably been among grad students and postdocs in the group like 1.5. So we break this rule all the time, but this is kind of what sort of keeps us all honest. So if you see one advertised, you can propose it to me. So one conference per year, we will make every effort to bootstrap. So for example, MRS in Phoenix, this is the last year it's going to be in Phoenix in 2020, and usually we can take multiple occupancy vehicles and accommodations and get there for relatively cheap. And as long as you submit an abstract for at least a poster, we can cover that, no problem. If I nominate you for the ARCS Fellowship, so my nomination letter for the ARCS Fellowship is, which is a fellowship that gives you $7,500 per year on top of your stipend if you had greater than or equal to 3.5 GPA in graduate school. Not my rule, that's just the rule of the ARCS Foundation. That money becomes your travel bank. So hopefully that's not too contentious of an issue, but that means that this kind of supplemental funding you can use to expand your education. Completely different topic, following the Tyler Cowen method of interviewing. Reorder supplies when they're down to 25%. Leave common space available. So we have too many people to have individual bench space. So there was, in my postdoc lab at the beginning of when we arrived, we were given a piece of masking tape and were able to carve out I Love Lucy style exactly 4 square feet of bench space. But then the number of students and postdocs approached a number where that was just impossible. And if you took the bench space and divided it by everyone in the lab, you would end up with 1 square foot each. So we, maybe 2. But it just can't happen. We just don't have enough space. Label all samples or suffer the consequences. So unlabeled samples, we're gonna make every effort to like, hey, whose is this? It's been sitting out, it's unlabeled, it's been here for like a couple days. But after that, when you are the last person to leave, lock the door, hope they don't have blasters, turn off the solar simulator, close the fume hood as well. So sometimes I'll be here on the weekend and both labs are dark, nobody's in the offices, and the door is just open. Fume hood is wide open, and they are variable flow fume hoods, so actually our energy usage goes down significantly when you shut them. Older fume hoods, it doesn't matter. Like they have the same flux no matter what, but ours are actually smart. Lock the door if no one is in the lab, even during regular business hours. And a lot of times we'll see stranger dangers, and don't be afraid to question others who are in the labs or who use our equipment. And this is lab etiquette, but also safety etiquette. We'll cover some safety issues later, but please close the waste containers if they're not actively being used. So this is in addition to EHS policy. It also, okay, I didn't close that waste container because I'm gonna go do this other thing for like half an hour, but the vapor pressure of the chloroform in there doesn't care when you're coming back. Like, it's just gonna keep on contaminating the environment. Absences and work hours in the group. So when I was a postdoc, this is just to show you that this is not just me being like a jerk about this stuff. I really do want to know like when you're not here. When I was a postdoc, one of my colleagues didn't show up for about 3 days and didn't call in sick. He had an illness and he didn't tell anyone about it. He passed away in his apartment and nobody knew. This was one of my postdoc colleagues. So vacations, personal days, sick days, mental health days, these are all necessary things, but please let me know. Okay, in general, you may work your own hours. I work my own hours. But it's better for the group if you're here during normal hours, at least a few days per week. And there's kind of a selfish reason and a magnanimous reason to do this. One is that I need to see you in order to advise your project. And the other reason is that the rest of the group will benefit from your knowledge, even if it's, you don't want to be pestered or whatever. That's tough nookies. My door is always open when I'm here. So I have this fruit fly distance of my door, which means that I'm available and not on the phone and not meeting with somebody. So if my door is like open, but just closed enough so that the fruit flies don't get in and breed in my trash can, that means that's like the green light. Ask me anything anything you want. And let's see, yeah. So I do work tasks. So I'm typically here 8:30 to now that I have a kid, 8:30 to 5, because I have to pick her up at daycare by 5:30. So I'll be leaving by 5 every day from here on out, with some exceptions. But I can't get done nearly everything that I need to do in those 8.5 hours. So you'll get emails from me at all times of day or night and on the weekend, and I don't expect a response outside of working hours. If you want to reply, great. I know other people I know what grad school and postdoc is like. And undergrad is like in a research group. I've been there and I worked all the time too, but I just want you to know that I won't think anything less of you if you wait till Monday morning or even don't check your email to send me a response. Okay, this is a little bit of guidance on writing from Rory. So writing a manuscript, follow the guidelines in our lab drive for writing an outline. Start with 4 central figures, expand as needed. So in the first draft of the outline, it really is about the figures. So I really want to know like the pictorial representation of what you hope to accomplish. If you draw them in colored pencil and scan them or take a poor quality photo of them, perfectly fine. It's just, it just doesn't make sense for me to comment on the scientific goals of a project if it's just text. So the text in an outline should really be the first paragraph. You could write that out in full, but then the figures are the outlines of the figures and the rest of the document. Okay, you can start with bullet points to get your thoughts down, and we convert it to prose in subsequent versions. Eventually, after enough iterations, we'll arrive at the final submittable version of the manuscript. This is from Rory. Anticipate, and I changed, I think he used a more colorful word here. Anticipate honest feedback from me, and he adds that it will make you a better writer. Thank you, Rory. Keep track changes on, but in subsequent versions, I don't need to see my changes again. So just accept those after you've reviewed all of them. Don't just accept all, and otherwise we miss the teachable moments. Okay, submitting the manuscript. So typically for most journals, what you do is you embed the high-res images directly into your source document. I'm a Luddite, so I don't know how to use LaTeX. So we're a Microsoft Word, crashy and buggy as it is, lab. Sorry, I just can't. I know it sucks, but I just can't. I can't do it yet. Yes, so embed your high-res figures. What's high-res? 300 pixels per inch, 300 dots per inch. And then the supporting information in PDF form. Suggest to me 6 reviewers. I'll add some. The editor doesn't have to take your suggestion. Also suggest an editor. Go to the associate editor page for the journal and find the people whose expertise you think matches closest to what's being done. So when in 4 to 6 weeks for most, let's say, ACS and RSC journals, you will get a referee report back. The referee report is written by, they're of a range of quality from 280 characters. I one time got one that would fit as a tweet. It was unfavorable. And sometimes you'll get referee reports that are 7 pages and really detailed. You have no control over who gets your paper beyond just suggesting certain people. The editor doesn't have to take your suggestions or may take one of your suggestions. And the reaction is not that these people want to destroy your career and that they never want you to be published and that they hate you personally. That's not the reaction to have when you get a referee report, although it's still the reaction that I have for the first 500 milliseconds of opening it up. Okay, sometimes a day. Sometimes it's actually best not to do anything with it until you've slept on it for a night, at least. And what is really priceless about the referee report, not too many R's, referee report is that it's a reaction. And somebody who gets paid maybe not a ton of money, but whose time is worth quite a lot of money, spent their expertise, their time and expertise reading your paper. And they will probably read it more closely than most people will in the future. So if there's something, that was in there, I put that in there, I'm going to tell them that it was already in there. If they didn't see it, it's probably not their fault. It's probably the writer's fault. Sometimes it's their fault. But if the argument was not clear from the way that we wrote the paper, you wrote the paper, I commented on the paper, then that's on us. So this reaction, and no one's going to die as the result of a referee report. So it's not that big a deal, right? But this is potentially hugely valuable because you know how your work is going to be received by experts in the community. So it's almost like free consulting services on your work. And if we view it like that, rather than as this antagonistic thing, then we will all be better off and have less adrenaline and cortisol in our systems. All right, the rest of this I'm kind of going to leave in up here for archive purposes, but we won't talk about it explicitly. Fellowships and funding opportunities. So there are a lot of things that are sort of US-wide and worldwide, but then some other opportunities that are UCSD or department only. Most of you are familiar with the NSF-GRFP and the NDSEG that require a 2 to 3 page research proposal, 1 to 3 page personal statement. And for NSF, you can apply once in your last year of undergrad and then once as a grad student, either your first or second year. I would advise people to apply. If they haven't applied in undergrad, well, everyone should apply in undergrad because you get that one for free. But if you're going to apply in grad school, apply in the second year. Just because you have a lot more time to put your best foot forward. Over time, we've done really well in these fellowships. Something like 11 or 12 Lipomi Group current students or former students have received it. I've also reviewed for the program twice, so I have a pretty good idea, like I know what they're looking for, I know what a good application looks like. So please start this process with me as early as possible, and I need to see your documents at least 3 times, probably 5 times each, your personal statement and your research statement. And I'm not gonna write the prose for you, but I'm gonna give you just really bracket honest feedback over and over and over again, and I can read it the way that a reviewer would read it. There are more specialized external fellowships, so computational projects can be funded through the DOE fellowship, the NASA Space Technology Research Fellowship as well. There are internal fellowships. Some of these you apply for or you're nominated for before you arrive, like the Jacobs and Powell Department Fellowships. But then as you go along, there are things like the President's Dissertation Year Fellowship. There's also the FISP program, which is a fellowship for interdisciplinary studies that can happen not just your first or final year, but any year in between, as long as you have 2 advisors on the project. Then there are sort of miscellaneous opportunities like the Achievement Reward for College Scientists. So if you have a 3.5 and a couple of papers, please apply for this, and the Grad Student Association Travel Award. And here's a pictorial representation of these fellowship programs. All right, so these are some things that pretty much everybody in the group is up to speed on. So your annual laboratory hazards training, a refresher is required every year. The UC Lab Safety Fundamentals is required every 3 years. You have to read and review your HCPs, your hazard control plans, get fitted for a fire-resistant lab coat. If you haven't done this and you don't, generally grad students and postdocs, you can go ahead and get one, but just for the sake of, we don't need a bajillion of these things. If it says that your name is Gerzaltovich Smith, that's fine, it's okay. We don't need to get 1,000 lab coats. Whoops, there's an errant cut and paste there. So Nano 3 access, You log on to the facility online manager and for the equipment that you want to use, and you get trained. At some point, you need to ask me for an index number. There's a place for a signature. I'm going to sign everybody's form. So who has the stamp in the group? Rory? There are probably, I've made probably 6 copies of the stamp. I really don't care, because security in today's age is about passwords, not signatures. So go ahead and stamp these things that you're sure I'm going to sign anyway, because why would I not? Okay. Mendeley has its own problems. It has fewer problems than EndNote. EndNote is a disaster of a program. I hate EndNote. I hope nobody raises their hand and says, I work for Thomson Reuters or whoever uses it or whoever makes it. One time in a class, I said that there was a particular analytical laboratory equipment class that I thought was a terrible company, and then someone raised their hand and said, my dad works there. Anyway, EndNote is a horrible and clunky thing. Mendeley is not perfect, but for me it has worked better. Okay. Some other things that you can check out. Lab cleanup. So every other week we will have 2 different teams that will alternate to do the lab cleanup. This is Mickey's purview here, and it will be after group meeting for a minimum of 30 minutes. And Mickey has done a really good job at organizing a bunch of photographic standards of how different parts of the lab should look. He's not here anymore. Charles took some nice photographs, and Mickey, equally importantly, uploaded them to the Google Drive. So importantly, don't just take things and put them under the bed. That is to say, junk drawers. If stuff doesn't belong in the lab, it belongs in the appropriate waste container. Cleanliness is also next to godliness, but also safety. So some cleanliness issues are clearly overlap with safety considerations. Chemical storage also overlaps with safety considerations. So we have several places in the group where chemicals go and where they're compatible. There are just a few things I want to say about this before I kind of release the slide, and you can kind of pause this slide on YouTube. The chemistry classics basically means non-reactive salts, so like sodium sulfate, sodium chloride, so on. Classic solvents are acetone, methanol, ethanol. Okay, thanks to Julian for putting together the next 4 slides, and I won't go through all of this in detail. What I do want to highlight is that every category of trash now has its own place. So there are 4 key categories of trash. So you have non-hazardous clean glass disposal, and by clean we mean clean. No residual chemicals, no throwing a 20 ml scintillation vial full of a fluorescent green compound in the broken glass container. Non-empty glass bottles. So this is where your fluorescent green compounds go, where we basically mark them out as trash as non-empty glass bottles that contain that have the constituents to your best possible ability marked on the container or on the label. Hazardous lab trash. So these are Kim wipes and gloves and petri dishes that have chemical, polymer, lab gunk on them. And we purchase these solids, these hazardous trash containers for solids. and also another one for waste-containing hazardous liquids. Finally, disposal of sharps. A sharp that is contaminated with stuff does not go in this category. That goes in the previous category. Sharp is like a clean sharp.
Correct. Sharps don't go in the buckets. They have their own separate sharp container.
Okay.
Yeah.
Contaminated sharps
Do not go in the buckets.
Contaminated sharps do not go in the buckets. Contaminated sharps have their own container.
Yeah.
Is that separate from the clean sharps?
Yes.
Okay. So the sharps have a contaminated container and an uncontaminated container. And we will leave it there for the purpose of the video.